Hello everyone, I am Pranav Jain, and in the last video we implemented queues using arrays, and in this video we will be implementing queues using linked lists. So we have already have done our implementation of linked lists, and if you guys haven't seen the video of this, I'll provide the link in the description and the cards above. So let's suppose we have this linked list, or we can call it a queue as well. So let's suppose we have this queue. Okay, so as the thumb rule in queues, we have to insert at one end and we have to delete at the other end. So if we insert in the beginning of the queue and delete from the end of the queue, what would be the complexities? For inserting at the beginning of the queue or the linked list would be very simple, as in we just have to update the head pointer, right? uh, like this, as we have already discussed in the linked list video. And for deletion at the end, as we are implementing singly linked list here, we have to traverse through all the elements in the linked list and get to the one element before the last element. We have to reach until the second last element and then point the second last elements next to null, right? We have to point 2 to null to delete 3. So this would take O(n) complexity, right? But what if we insert at the end and delete from the beginning? That can be done, right? Because deleting from the beginning, we just have to update the head pointer to 1. We'll say head is not 0, head is equal to head dot next, which is 1. That will delete our first element. And for insertion at the end, we would be having a different rear pointer in queues. Like we have, this would be front, and we would be having rear that would be pointing to the last element on the linked list, and we would simply say rear dot next as our new element in the linked list or the queue. So both the operations will be done in O(n) complexity. So now let's start with the implementation. As we all know, there are these 5 basic methods: insertion, deletion, isEmpty, peek, and print, that we implement for queues. So let's quickly create the structure of all these. We call the insert operation as enqueue. We call the delete operation as dqueue. And we will implement isEmpty. We will also implement peek, and we'll also implement print. Let's create a private class for representing each node of the linked list. We are considering each element as int. Let's call it data, and the reference to the next node is next. Now we create our 2 queue pointers, front and rear. Initially both will be null. Let's write in this line only. Okay, so both are null. So when both front and rear are null, that means our linked list, our queue, is empty. So we can quickly add this condition in here, return if our front is equal to null and rear equals to null. That means our queue is empty, else it means it's not. Right? And for peak we can simply return, let's suppose the peak method that we are creating will return the front element from the linked list. So we'll just simply say front dot data. Okay. So we have implemented isEmpty and peak method. Let's quickly implement enqueue method. So we know that we will be inserting at the end of the linked list, right? So the in general what we have to write, let's first create a node. Also let's create a constructor in this. Okay, so this would be the parameterized constructor which would contain data and next we can say this dot data equals to data and this dot next equals to next. Okay, so public. Now we can write like this, a node, let's call it temp, or let's call it new node equals to new node, and we need data as element, and our next would be null. Right? So what I have to do, the rear pointer will be pointing to the last element. So I have to point rear dot next to this new node. Right? That I can do using rear dot next equals to simple new node. Right, and now I also have to update this rear to this last element which is our new node. Right, but what if we have empty linked list? We have to check that condition also, because then rear would be null and there would be no next of it. It would give me null pointer exception then. In that case we would have to check if our linked list or if our queue is empty, then what we can do, we can simply say that our first element is this, so we have to update both our pointers, front and as well as rear. So we will say front equals to new node as well as rear equals to new node, and we'll simply return from this. Okay, so we have successfully implemented enqueue, which is implementing at the end of the linked list. and dq we will be implementing at the beginning of the linked list. So for deleting from the front, we just have to say front equals to front.next, and that's all we have to do for deletion. But we also have to do a check, as in when we are deleting, like when we are deleting and we reach to the position when our rear and front are same. What I mean to say is, let's say this was our initial linked list. Okay, and my front was this, my rear is this. Now I delete one element, so 0 is deleted, front is pointing to 1 now. Now I delete 1, front is pointing to 2 now. Now I am deleting 3, front is pointing to 3 now. Now if I say front equals to front.next is pointing to null. That means I have to say this element is deleted and my rear is pointing to this element. So if I just update my front pointer to null and rear will remain same, then it would bring inconsistency in my linked list, because my last element is before my first element and I don't have any first element also. So I have to update both the pointers. For deleting the only element in the linked list, I would say front and rear both will be pointing to null, right? So I will simply say if front is equal to rear, then front equals to null, rear equals to null, and return. With this our deletion is also complete. Now let's print our queue. How can we print our queue? It's very simple. The way we traverse in the linked list, our temp would start from front until it reaches rear or null, right? So while front not equals to null, I'll simply say print front dot data and just a little bit formatting, and oh, I'm sorry, this should not be front, it should be temp. Temp equals to temp dot next. Okay, so this will print our linked list. Now let's check our methods. Create a main method and let's see if our methods are working right or not. Let's do test in the similar fashion we did for the queues implementation with array. I'll say queue implementation. Okay, so what we are doing in this test case is we are inserting 1 2 3. So as we are inserting in the beginning, as we are inserting at the end, it should be 1 2 3 should print, and then we remove 1, so now it should print 2 3. Then we are seeking the front element, it should seek 2, and then we are deleting both and checking if it is empty or not. Okay, let's see, n is empty should return true. So let's see if this works fine. Okay, so 1 2 3 is printed, then 1 is deleted, 2 3 is printed, and we have peeked the front element which is 2, and then we have deleted both and check if it is empty, it returns true. So our program is working fine. This is how we implement queues using linked lists. That's all with this video. Let's see you guys in the next video.